Okay, guys, so this one's going to be triangle CDE was graphed in a coordinate grid. Triangle CDE was reflected. Reflected automatically means to go keep congruent, guys. Once you reflected, there's actually several of them. Reflected, translation, and rotation all mean congruent. Make sure you know that. This is going to be for the rest of this video. Congruent. So just look at the words congruent. Not equal, out, not congruent. Greater than doesn't mean anything like that. So congruent. D is the answer. Okay, question. Reflected again. Again, reflected. The three words again will be, in the order we started them, were translation, and then we went to reflected, and then we went to rotation. All of these things mean, again, congruent. So just in case, the other word that we have is dilation. Dilation is different. That one, we go automatically to not congruent. And it also means to go ahead and be similar. I'll give you a quick example. This right here, I'm going to copy it and then paste it. So those two things are congruent. That's congruent over the same size, same everything, right? And we go to paste a couple more. And these two right here are going to be congruent until I do that. So those are similar, not congruent. This is congruent. So these are here. Reflected, go to be greater than out, less than out. Those are out, out, twice. No, congruent is the answer again. Okay, so trans 6 years to the left. This is really translated. It means to add or subtract on the x-axis. I can't see up there, but I want 6 left, right? So we see 6 left. Nope, nope. These are nothing we've ever seen. Those don't ever work out like that. So 6 left. D is the correct answer. This is an easy but hard question. It's easy if you can't understand what's going on here. Basically, this transformation does not produce a rectangle with the vertices of the same coordinates. So I want to just like draw over it. This is a coordinate. This is a coordinate. This is a coordinate. Those are your vertices, right? And if I have a rectangle on top of it, and I go ahead and do several things, they want it. It doesn't happen. It doesn't wind up in the same spot. Well, what do you mean, sir? So if I turn it like this, you see how they wind up back in the same spots? And this was hard for me to draw, but imagine if I could reflect it over the y-axis. And y-axis makes sure this half would go over here, and then this half would wind up over here. So translations, rotations, and all these things kind of would wind up back at the same coordinates. The one that would not wind up at the same coordinates, if you actually pick up this thing and drag it over. And that's a translation. And to identify translations, easy. These are translate. This is a translation right there. Okay, so translation just moves it out of the way. It does not even keep it in the same coordinates. So let me see the change. Oh, that's it. Okay, so let me see. Let me go back over here. Come on, change. This is really easy. Basically translated, again, we did a while ago. So on the x-axis and the y-axis, this is the x-axis here. We're going to have x. Anything to the left will be negative. Anything to the right will be positive. Y-axis is going up, positive. Anything going down, negative. So we're going to go here. The coordinates, I don't even care where they're at, but they're going to go to the left. So going to the left, anywhere, going to the left is going to be minus. Minus how many? 4. So it's on the x-axis, so we're going to x minus 4. So x minus 4. And we're going to go 3 up. Anywhere at. It doesn't matter where we go. We'll go 3 up over here, 3 up over here. That's going to be y plus, in the y plus direction. We're going to go to y plus, the same one, number 3. Y plus 3. Because this is like the other one earlier. Basically, what's going to happen is some kind of movement can be done to this thing, and they don't want it. Let me see. Which transformation does not produce a square with the vertices of the same coordinate pair? So we don't want to draw the square. Again, just regurgitating or restating what I said earlier. If I turn it, it winds up back on its same vertices. We don't want that. We want the different vertices. If I get the half, imagine this half, and I reflect it over the y-axis, this half would wind up here, and this half would wind up here. They're both 2 units off, so it still wind up in the same vertices. The same thing for the x and x-axis. If I go up or down, This half would flip over here, wind up on that. This half would come down here. So on all this madness, when would it not work out? When would it not wind up on the same vertices? When would it just change completely to a different spot? If I were to pick up the whole thing and slide it on over. And so that's going to be this one. And I think that's it.